Okay, so we're going to have a look at another question from ordinary differential equations. So we've seen quite a few ordinary differential equations at this point. We're going to have a look at a different one now. This is going to be a third order. So we have y prime 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 minus y prime is equal to 2e to the x. So here we need to find a full solution. So we're just told to solve, and we need all of the possible solutions here. So find a general solution which solves this differential equation. So this kind of differential equation is going to have two separate parts. We're going to have our normal solution equation, which is going to give us our standard general solution, and then because this is not equal to 0, because this is equal to a function of x, it's also going to have a particular solution. So we'll have a general solution, a particular solution. The total solution will be the sum of all those. So let's start with the general solution first. So y prime 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 minus y prime, we're going to assume this is equal to 0. So to find the standard general solution, we just imagine that the equation is equal to 0 in order to get the characteristic polynomial, solve accordingly. So this is r cubed minus r is equal to 0. If we factor r out, this gives us r in front of r squared minus 1 equals 0. So this tells us r is equal to 0. R squared equals 1. So this gives us r is 1, or r is minus 1. So we have three solutions here. R is equal to 0, r is equal to 1, and r is equal to minus 1. Now when we're solving these types of equations, if we get real distinct roots, the solution y of x, the general solution, will take the form a times e to the r1x plus b times e to the r2x plus c times e to the r3x. So this means our general solution will be y of x is equal to a e to the 0 plus b e to the x plus c e to the minus x. So this is our general solution in this case. And the e to the 0 we can just write as a 1. So we can say that this is just a plus b e to the x plus c e to the x. So here's our standard general solution. We've done this the way we've done pretty much all of the other second and third order DEs. But now we need to find a particular solution. So we need a particular solution as well. The way we determine a particular solution is we look at the term on the end. We look at the 2e to the x, and we try and guess based on this what a possible solution might be. Now for anything of the form a e to the alpha x, a standard guess is a e to the alpha x. So this is an ordinary guess, but we already have something that's in the form of a e to the alpha x, where a is b and alpha is 1. And alpha is 1 is the term that is the case for the term 2e to the x. So we have to pick something else. A common so this won't work. A common alternative is ax e to the alpha x. And this is actually what we're going to do here. So we're going to assume that ax e to the alpha x is a possible solution, and then we're going to test that. So we have y particular, so this is y general, this is y particular of x, is equal to ax e to the alpha x. Now alpha is of course 1, so this will be ax e to the x, but the a, we already have an a up here, so we'll call this a different variable. We'll call this dx e to the x. x e to the x is not used in any of the terms in the general solution, and so this is a good sign. So our y particular is apparently dx e to the x. We can differentiate this. Y prime particular of x. We can do this as a product rule. So u is dx, v is e to the x, u prime is d, v prime is e to the x. So this becomes u prime times v plus u times v prime, which is d e to the x plus dx e to the x. We can then differentiate this again. This will give us y prime particular second of x. d e to the x is just d e to the x. dx e to the x we know becomes d e to the x plus dx e to the x, so this is 2d e to the x plus dx e to the x. And then we can take a third derivative as well. This gives us y prime 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 particular of x is equal to 2d e to the x becomes 2d e to the x. dx e to the x becomes d e to the x plus dx e to the x. So this is 3d e to the x plus dx e to the x. So now we have our first derivative, our second derivative, our third derivative. We have our function. We can plug some of these in to the equation we were given initially. So we find that y triple prime minus y prime is equal to 3d e to the x plus dx e to the x minus y prime, which is d e to the x plus dx e to the x. Now we have 3d e to the x minus d e to the x, that's 2d e to the x. And then we have plus dx e to the x minus dx e to the x. So this is 2d e to the x. And this is true when d is 1, because we know this is equal to 2e to the x. So this is solved when d is equal to 1. So this has actually solved our d value for us. So this implies that the y particular solution of x is actually equal to x e to the x. So we have x e to the x. Because we have all of this, we can now write our full solution. So we've got, so the full solution is going to be the combination of both of them. We have y full of x is equal to some constant a plus b. So we had our general solution b e to the x plus c e to the minus x, b e to the x plus c e to the minus x, plus we've just found out that d is equal to 1, and our y particular consequently is x plus e to the x. This is plus x e to the x. And this is our full solution for this particular differential equation. Now we can test this. So we can take the first derivative of it, the second derivative of it, the third derivative of it, plug them all into our initial ODE over here to confirm that this is true. And of course we are going to be doing this. I'm going to slightly shorthand the derivatives to save space, but we get y full first derivative of x is equal to b e to the x minus c e to the minus x plus e to the x plus x e to the x. Y full double prime of x is equal to b e to the x plus c e to the minus x plus e to the x plus another e to the x plus x e to the x. And then we get the third derivative, y full triple prime of x is equal to b e to the x minus c e to the minus x plus 2e to the x plus an extra e to the x, that's 3e to the x plus x e to the x. So we have our function, our first derivative, our second derivative, our third derivative. Now we can plug them in to the ODE that we started with. So this implies y triple prime minus y prime is equal to y triple prime, which is this. We have b e to the x minus c e to the minus x plus 3e to the x plus x e to the x minus y prime, the first derivative, which is this, b e to the x minus c e to the minus x plus e to the x plus x e to the x. This is apparently all equal to 2e to the x. So if we simplify this, we have plus be to the x minus be to the x. We have minus ce to the minus x plus ce to the minus x. We have 3e to the x minus e to the x, and then we have x e to the x minus e to the x. 3e to the x minus e to the x is 2e to the x. 2e to the x is equal to 2e to the x. This is true. And this confirms our solution. This confirms that our full solution is a full solution to this particular ordinary differential equation.